about an idea that I call Robusto, or you can think of it as a modest proposal of what I think should be the TLS of open source supply chain security. Slight change of title, don't worry, it's the exact same talk. I just thought that having a memorable name is good to have the name, the idea stick. I also have slightly more than 10 years of experience now in supply chain security, having worked on it, from my grad research and now in my capacity at work. And I'm active in some communities in the space, such as Stuff, Uptane, Toto, Sixdoor, Salsa, SBOMED, probably a few more. Anyway, moving on. So if there's nothing else you remember from this talk, I'd like to present the bottom line and the summary later at the end of the talk. The idea, if you remember nothing else from Robusto, it's this. It's a tech stack that when composed gives you very strong security guarantees about your software supply chains, right? And you can think of it, if you think of software distribution as the problem of securing, the delivery of vaccines from source to end to consumption, shooting it in people's arms, it's sort of like the following. So Robusto consists of in toto, which is the first layer of technology at the lowest layer that says, it's sort of like Pfizer or Moderna saying, hey, here's how I made exactly my vaccines. Okay, here's all the ingredients in it. This is who I sourced it from. This is how I put it all together. This is how I tested it. And finally, my little holographic sticker seal, saying that nobody tampered with it. And then Tough is the secure transport protocol for in toto and artifacts on top of that. Sort of like the FDA in the USA that says, okay, today I approve Pfizer, tomorrow I approve Moderna, and tomorrow the day after that I approve J&J, and maybe later after that I may revoke some of this. Point is, Tough is like the layer that tells you who to trust and what to trust, what is the latest source of truth and all that sort of good stuff. And last but not least, in this tech stack, Sixdoor is sort of like the CDC using the Library of Congress in the USA to record the entire end-to-end history of exactly how every single little vaccine or package was made. So you can look it up, permanent, immutable record. Everybody can transparently and audit and monitor this. Okay, so but why are we? Let's set the scene. Let's set the context for all of this good stuff. Here's the problem, right? The problem is supply chain attacks. I'm preaching to the choir. We're probably going to be hearing this a few times, okay? And then we'll all probably be a little bit tired from hearing this at the end of the conference. But the point is, this is no longer the realm of bad Hollywood movies, right? Supply chain attacks are very real. And this is just to choose 3 very high-profile attacks in just the past few years alone. It's so serious that the Biden administration is taking it seriously and talking about it in an executive order. So we all know we have to do something about it. Security is no longer optional. We have nation-state threat actor groups coming after us. And my worst nightmare to this day remains the compromise of open source software package repositories, okay? We've all seen supply chain attacks where, someone manages to compromise, a few developer accounts here and there and, tamper with this package or that package. I'm talking about something bigger. I'm talking about, imagine taking over an entire repository and tampering with all packages potentially. That's a nightmare doomsday scenario. Okay, it's sort of like like a nuclear apocalypse of our industry. Okay, so this is the thing that we're keeping in mind. And then the threat model, I claim that if you have a threat model that's sufficiently powerful like this, you just start from day one. Just think of the most realistic but most powerful attacker you can think of, okay, which is this nation-state attacker. Can take over an entire repository. And Salsa, our friends at Salsa have come up with this very nice way to think about a supply chain threat modeling. And it's quite simple conceptually. Every supply chain is made up, no software is an island. We all depend on each other. So you have dependencies. Attackers can go after that. They can compromise source code itself, repositories. They can compromise build platforms. They can compromise the package repositories, the final last mile, as it were. Okay. And then not to mention all the man-in-the-middle attacks in between. Okay, so just keep life simple and treat it as such. It's not a question of if, it's a question of when. Things are going to get compromised, and there's so many ways to get into a supply chain here. So just assume it will happen and design accordingly, prepare accordingly. Okay, and how do we do this? I claim that we need to meet a security property that I like to call transparent, compromised, resilient. Bit of a mouthful, isn't it? And need to be careful with the definition here. Would love to go deep into details, but we don't have the time for it. But so let me try to give you a flavor of it using metaphors. Imagine you're a king in a castle, maybe transported back to Game of Thrones or Lord of the Rings or whatnot. Okay, and you know, someone looks at you and says, "Oh, I heard you're a king. You many people must try to break into your castle all the time. Must be no fun." But guess what? I can build you an impenetrable fortress. Immediately, your eyebrow should raise and go like, "Wait a minute, there's no such thing as an impenetrable fortress," and you would be right. And look, we've had hundreds of years, if not more, in actual physical engineering out there. We know how to build castles that are harder to break into, infeasible, okay? Not impossible. It's the same thing in cybersecurity. So the same metaphor here, we want compromised resilience. So the way they used to build castles, you know, they were layers of defense. Maybe you have a moat of water around it, and then you throw in alligators there just to be super safe. And just to be even safer, you put a guy with a flamethrower in front of the entrance to the bridge over the moat in the first place. And then, you know, people used to build castles, and, you know, they have multiple layers even inside the castle. And then, you know, they even build castles on top of hills sometimes. So anyway, we have learned from painful experience from the real world. We really should be bringing, transporting, importing into our industry. And the transparent part is this, like, look, you have all of this layer defense in depth, and the attacker looks at it and goes like, oh my God, forget about it. I got easier target. It's literally this fellow next door who keeps his keys under the mat, so to speak. And then, you know, but still, you want like a detective or a watchman or a night guard, whatever you want to call it. That's the transparent part, where someone is always going in and checking in all the security still works and nothing has actually been broken into, right? So put all this together. Okay. So how do we do this? What's the status quo? How do we get there? Well, where do we begin is the question. We have a lot of wonderful technologies out there. A lot of these are friends of mine. I'm actually even involved in some of these communities. But you know, there's at least 3 software foundations here, right, involved in this project. There are various projects under them. There's old time tested technologies like GPG and SSL. And then there's things like transparent logs and so on, which has seen applications elsewhere, especially in SSL. And now the question is, especially for someone who comes in, you know, developers look at this and go like, okay, where do I begin? What should I start? What horse should I bet on? Because right now it's not clear. Even in the USA, we have regulations for like things like producing S-bombs. But that's about as far as compliance, and even that's not necessarily a hard requirement, not just yet. And so, okay, and signing is certainly not, you know, still fairly optional. So the question is, okay, what do we sign with? How do we verify? Do we have a standard? No, we don't. Situation is not helpful for repository administrators either. They're looking at things and going like, well, look, first of all, we're open source, you know. Many of us probably work in open source here. You know, resources are constrained. And so, you know, and then finally, end users are not even thinking about this, right? Rightfully so. Security should be transparent for them. We build it for them, and they don't think about it unless something goes wrong. Okay, and that's the state of affairs. That's what it should be. So anyway, what do we do then? What's the solution? Well, I propose we come up with a tech stack, just like LAMP turned out to be very useful for really taking open source to the next level. It's a composition of technologies. I mean, look, it works even for superheroes and giant transforming robots. Each of these, you know, heroes, robots, they have their own strengths and drawbacks, okay? You have a real big problem, like say Thanos. You want to assemble the best of the best, the cream of the crop, so to speak, and put them together. And so you know, the drawbacks sort of cancel each other out, and you tap everyone's strengths. And so, you know, that's what we want here. That's how we want to build this security system. You can think of it as the TLS of supply chain security. Okay, so the idea, tech stack, we take the best of the best and try to solve the problem here. And that's the solution that I'm proposing here. It's Robusto. And again, going back to the analogy, it's a tech stack composed of 3 different technologies. I'm not going to repeat myself too much here. But the point is there's in toto, there's stuff in Sigstore. And let's take a look at how they all each work in turn. So the first, in the lowest level of things, if you look at the supply chain, what is a supply chain? Well, a supply chain conceptually is a series of steps, all the way from source code to producing the artifact at the very least. Okay, and then every supply chain sort of looks different, but we can roughly generalize it and say, for example, we can worry about things like who wrote the source code. And so the way in Toto, the way it works is it's sort of like solving the game of telephone here, right? So if anything goes wrong here, there's noise in the transmission, which you can think of as an attack, you can catch it. So in Toto is made up of at least two different things conceptually. One is attestations. There's either people or machines will sign an attestation swearing this is the inputs and outputs. The inputs we got and the outputs we produced, and these are all the environment parameters and variables that went into to do what we did. And so you can double check us, you can check us. So a developer can write an attestation saying, well, this is the source code I produced. I don't know what happened next. And then a CI, such as GitHub Actions, in this case, will say, well, I don't know what happened, but I got this source code from this developer, and I built this package. That's my output, right? And then the next step is you can say, a repository like PyPI in this example, for example, would say, well, I don't know what happened, but I got this package from GitHub Actions. So someone who composes a policy, and this is where the higher level information comes from. You compose the steps. You say what your supply chain looks like. So if there's an attack here, say someone compromised a PyPI credential for one of these developers for this project. Great. And so they try to upload a malicious package, and in fact, they succeed. Now, fortunately, because we have this policy that says how packages are to be verified and trusted, you can check, well, hold on, just because someone uploaded a package, you will have the attestation from PyPI saying, well, that's the package we got. But the question is from who? And if attackers, that's the thing. You want to make it harder to attack, right? So if attackers haven't compromised GitHub Actions, or at least the pipeline, the repository used to run this pipeline, they won't be able to forge that attestation from GitHub saying that that's the package they produce. So first of all, this if you put the two it won't work. The policy will prevent that package from being trusted. And you can go even deeper and say, yeah, okay, even if they manage to compromise the GitHub Actions pipeline, on top of it, can they make up arbitrary source code? And if developers sign and review each other's source code, no, this cannot be done. You have very strong supply chain security here. We solved the game of telephone problem. Attackers can introduce noise into the system, as it were. So the metaphor here is, again, sort of like Pfizer or Moderna saying, yeah, okay, so this is what do you call? This is how I made my vaccine. You can check, it's gluten-free, for example, if you care about that sort of stuff. Okay, and then the next layer, the next layer in the technology is, you can think of TUF as the secure transport protocol for in total supply chains and artifacts that in total ultimately talks about. Okay, and TUF is on top of that. TUF is the thing that will tell you, that gives you compromised resilience, right? TUF is the thing that will tell you. So if you're a registry like Ruby Gems in this particular example, look, we're going to start in the world where you're not going to be able to introduce in total overnight. You're going to slowly introduce one type of attestation, then another, then whatever else you like, and then putting policies together on top of that. So we're not going to be able to wake up to a world tomorrow where we have all this in total metadata. So you need to start practically. You need to start practically in a world where you need to divide packages into two classes. One is packages without these policies. And so the repositories will begin. Most packages will probably be here in the first place. Repositories will be signing on behalf of developers, right? And CI platforms and so on. So the compromise here, the trade-off here is that someone who compromises the repository can, of course, tamper with these packages here. But here's the good news. We can slowly start moving, slowly but surely, to a world where packages are protected at rest with these policies that I talked about, so that, it's not enough to just compromise the repository because they're not able to produce forged signatures for all of this other metadata that came, and we're signed with separate sources, completely separate from the repository. So attackers who, even if they manage, this is what I mean by compromised resilience. You don't want to be a complete game over scenario. And in fact, if one day we move to a world where most packages are here, at least the top critical dependencies of open source are here, that's 80% of the way already there, right? Because the popularity, the power law distribution of packages, how they're consumed. If we just move like a few hundred packages selectively here, that's major security win right there for everybody. And then there's some devil in the details about what Tough does that unfortunately I don't have time to go into. There's just no time for details. Forgive me. But, Tough also takes care of things that people rarely think about, especially things like, protecting dependencies. You don't want attackers to tamper with that. This is important in a open source repository. Things expire naturally. You can renew them, of course. And more importantly, you even get protection rollback. Even if attackers cannot reproduce signatures, what if they try to roll back you against an valid signature, but you shouldn't be installing it because it's got a known CVE, for example. So anyway, so Tough is, again, going back to the metaphor, sort of like the authority you trust. You have one root of trust, and then from there you can establish trust of everybody else in the ecosystem. Okay. And last but not least, Sigstore, which probably most of us here are familiar with, Sigstore is a few different things, at least. There's record, which is a transparent log, tamper-evident log, Merkle tree, in other words, classic data structure from at least the 70s, if I recall correctly. And then it's got a few other components like full show and cosign, which we don't need to get into here. For our purposes, for this talk, the key thing we're borrowing from Sigstore is this genius idea of storing the the history of things. So it's an append-only log. You can only add to things. You can only add to the log in a growing. Think of it like an amber. That's the fella from Jurassic Park, by the way. Think of record as an amber that keeps growing more and bigger over time. And you cannot tamper with it because you'll be caught, especially because different independent parties are auditing it all the time. Okay. So you can now record the end-to-end history of, going back to that vaccine metaphor, sort of like the Library of Congress here that we have in America, where you add a permanent record of everything that we've ever produced, every package. And you can look up you can look up the tough metadata, the internal metadata from the artifact themselves, and now we have cryptographic auditability. There's no deniability here anymore. Okay, so now someone might say, wait, but you forgot to talk about this system or that system or this system. What about that? Look, I'm talking about a tech stack that in my mind is sort of like the MVP, the bare minimum we need to meet that security property that I call transparent compromise resilience. We can add other technologies here. In fact, it's fundamentally designed to be able to add plug and play other things that should be added to the system. What I'm trying to say is that if you want transparent compromise resilience, this is the bare minimum we need to be able to protect ourselves from nation state attackers. The rest is optional, so to speak. And we can always build, but my point is we need to build a solid, strong, secure foundation. A good foundation is key from day one. And so happy to discuss more and more in the Q&A later. So anyway, in a nutshell, Robusto is again a tech stack. Going back to it, it's composed of in total, we record exactly how the every package was ever made from source to packaging. Okay, they define the artifact that was output, and then we use stuff as the secure layer to bind artifacts to in total metadata about the supply chains. And then last but not least, Sigstore records the entire end-to-end history of all of these things. Okay, we have this beautiful system here. And again, unfortunately, I don't have time to go into details, but look, I just, if there's one thing you remember here, okay, it's that, look, there are all these features that we care about. And if you look at, remember the analogy I used earlier about superheroes and transformers and so on. Individually, each system had its strengths and drawbacks. Again, if you have questions, you can press me in the Q&A later or offline. My point is, look at Robusto. It's designed to by the careful composition of the systems, we're able to get the best of all worlds. So that is the point that I'd like you to remember here. So in conclusion, in a nutshell, I'm going to leave 5 minutes for Q&A ideally. So look, again, we don't have, it's still early days for supply chain security, especially open source supply chain security. It's still, the dust hasn't settled yet, so to speak. And we need to get together as a community to design and implement together this system, a system that we need like I said, like our own TLS. And remember, it's not just about key distribution here. I use, yes, TLS as a metaphor, but mostly to show the idea that TLS works without users thinking about it. Grandma is able to use TLS without knowing anything about how it works, and that's the way it should be. Heck, even I'm not an expert in TLS. That's the same thing that we need for supply chain security here. Right now, all of us still need to think about it. Never mind grandma. We don't want to give grandma a hard time. So we need to build a nice system for her where we're able to protect her from nation-state attackers, okay? And hopefully that's the bottom line that everyone remembers here. It's a tech stack composition of Intodo, Tough, and Sigstore that I claim is the bare minimum here. Okay, thanks. I think we're right on time, actually. If you'd like to see, again, this is a proposal. If you'd like to see Robusto as an actual thing in open source, I'd love to talk to you. There's the software, securing software repos working group in OpenSSF. We can also use the repository service stuff, as my friends talked about earlier, in the 6.0 Stack Slack also. Yeah, please come talk to us. I'm also available through my website. Yeah, let's leave time for questions and answers. Thank you very much.
Let's thanks Trishank. I think for questions, again, we should just do that on Discord. Oh, we do. Let's check that. Yeah, should we? What should we do? Mm-hmm.
Trishank, can you hear us?
Yes, can you hear me?
We hear you.
Yep.
Great. Hello, everyone.
Yeah.
Actually, Trishank doesn't want to show his camera, so we are left with a voice.
No, sorry. It's not that I don't want to show my camera, but but need better lighting, I suppose.
All right. Let's see. Do we have any questions in the room? So there is a question on Discord. It's a question from Kevin Midman. Question about anti-rollback. Does that mean Tough doesn't support removing a package from PyPy?
Oh, that's a good question. Well, the short answer is no. Tough does support it, and the question is, it becomes up to PyPI and even up to developers to some extent what they want to remove. Does the notion of snapshots evolving over time? You can always choose to remove certain packages from the current snapshot.
All right. Any questions in the room? So I have a question. So what is it wasn't entirely clear to me. So what is the current status of all of this? So are you working on this, and what are the future plans?
Yeah, good question. Thanks. First of all, sorry I couldn't be there in person. Secondly, thanks for accepting my talk. To answer your question, yeah, right now, so like I said, this is a proposal. There's no code for this yet. This is something that I've been thinking about for a while, while watching, current efforts in the space. Like I said, if there's interest, would be curious to work together with some of you to get some of the code going. And especially we have some wonderful efforts like RS Stuff and of course, all these other great projects out there. Would love to get something going. And if it's mature and serious enough, maybe we can even think about, officially incubating it as a project at one of the software foundations.
All right, thank you. Anybody? then I think it's time to move on to the next talk. Thank you so much, Trishank. Let's thank him again.
Great. Thank you. Thank you very much. Bye now.